Okay, thank you. So I want to talk about documenting ML experiments in HELIPORT. I want to start by introducing our data management guidance system HELIPORT and some examples of ML experiments that people are doing at HZDR. And then I want to talk about some aspects that could be documented better about these experiments and how HELIPORT could help in this scenario. I want to give a brief disclaimer at the start. I'm not a machine learning expert. I work on data management mostly. And I don't want to present a turnkey solution or anything. I want to present some initial ideas that we had on this topic, and I would be glad to talk to you afterwards and get some feedback on these ideas. Okay, so HELIPORT, I already said the term data management guidance system. We want to help guide researchers through the data management landscape that is provided at HZDR and help them figure out which systems and tools exist and which they can use. This was a HMC project from the Helmholtz metadata collaboration, so this was a nice metadata topic that was funded by them. So you can see in the interface, you can see these categories of resources that people can link, I will present some of them briefly. So the most basic feature is that you are able to link resources like documentation, publications, software that was used in a project, data archives, and so on. And this is a simple way to collect resources of a project, which helps both current and future you remember all the things that were involved, and it also helps onboard new colleagues when they join a project. Also, all of these resources that are linked are represented by digital objects, and they get landing pages with globally unique persistent identifiers. In our case, we use handle.net. And these landing pages show some semantic properties. For example, in this case, you can see that it is an archival document, which is represented here. You can choose for certain aspects of the metadata how much you want to show to the public. And there are different metadata export formats available. For example, bibliographic metadata in the data site format, but also the more semantic things with various RDF serializations. One of the features which has some more functionality is data sources. You can link data sources in HELIPORT, which allows you to browse them and set certain tags on them, on certain files and directories. Different kinds of protocols are supported. And we don't store any data inside of HELIPORT. You link your existing data sources that are, for example, on network file systems and so on. You can link them. And one more interesting feature is the setting the publication tag, which you can see in the first example here, which allows you to automatically publish your data sets as data sets on Rodare, which is our internal Zenodo clone. Another feature is the digital object graph, or you can have multiple in each project. And they show relations between resources. Currently, and you can use them to visualize different facets of an experiment. And currently, these are created manually. You have to create them manually, which, of course, is error-prone. And we noticed that users don't really see how to really use them and see the possibilities. They are not clear at the moment, and so we want to automate this process of creation of digital object graphs based on ontology-based metadata. And the first use case we had in mind for this is using, some people use SnakeMake to automate their ML experiments at HZTR, and we would like to use the output metadata from SnakeMake, transform it into the workflow forever ontology, and then have a generic way to display these metadata in digital object graphs. There's some examples of ML experiments at HZTR. These are from the local Helmholtz AI unit. Helmholtz AI exists throughout Helmholtz in different centers. We have a local unit which consists of a consultant team and one young investigator group. And the top two examples are from the consultant team. The first one, approximation of linear energy transfer, which is important in radiotherapy, which can be approximated using deep learning. The second one is an example which can be used throughout various things in fluid dynamics, which is instant segmentation of bubbles. In this example, they are artificially created in simulation, but this is also applicable to real-world experiments. And another important example are surrogate models and virtual diagnostics for certain stages of laser-driven particle accelerators. And this is an important experiment where people are working on the idea of digital twins. Okay, and so we considered to document these ML experiments better, we would like to embed them in larger contexts. This means, for example, we have data sets which are from real-world experiments. And this means they could change. They aren't just some downloadable, ready data sets. Also, we see often that the users of the created ML models, they use code which is often not very well versioned or packaged, but rather passed around as Jupyter notebooks, and people make then tweaks to these notebooks to accommodate for their use case. And also we considered that model outputs may actually influence experimental setups in the real world. So based on a model output, beamline scientists might consider changing laser parameters actually. And we would like to generally make a better connection between the ML model and the large-scale facility. So this is the digital twin idea again. Interesting ML metadata which we could use are model configuration and performance, for example, and also the compute resources that were used, which is increasingly more important. And some relevant digital objects that people might want to link in HELIPORT would be training data sets, trained models, which are dumped as files, for example, and the software they used in the process. So when we discussed this first, there was a question that came up, which was, can we support scientists by integrating ML ops in HELIPORT? And we talked about this a bit, and it turns out this is probably not the best solution, because many of the aspects of ML ops aren't really applicable to the ML experiments that are actually done at HZTR. So they are often prototypical, they have iterative development, and also I already mentioned they are, the ML people are either consultants or just plain scientists working with ML, and they aren't really service providers or infrastructure providers. So many of the aspects just don't work. And yeah, the goals that they have are more rooted in general open science ideas like reproducibility and transparency. But ML ops still might come into play at a later stage. For example, when some of the ML experiments were successful and a usable model was the outcome that domain scientists actually apply in production. And but this also requires that a common way to interface with this model needs to be found, because at the moment it is often the case that people just pass around on a USB stick the dumped file of the model, which is not so convenient. Okay, so we also looked at some ML tools that people are currently using. One of my colleagues uses TensorBoard, and I also had a look at weights and biases, just 2 examples. There are many more tools available. And from the data management point of view, I looked a bit at provenance information, and TensorBoard itself is actually only a visualization tool for certain ML metrics and data. And this idea of artifacts or provenance isn't really baked in. If you are more into the whole TensorFlow extended, you use other TensorFlow libraries as well. There are certain metadata libraries with artifact types, for example, which can have arbitrary user-defined metadata. But for example, one of my colleagues uses TensorBoard, but actually with PyTorch in the backend, so this isn't really applicable. Weights and biases similarly has artifact types, which can be considered like files or directories, but they only have a fixed set of defined metadata. And in general, these tools only cover the machine learning domain, which makes sense because what else would they know? And we would like, as I said, to embed this in the larger context. So we had a look at some ML vocabularies and ontologies, and I would just like to get an idea. If you have a look at this list of ontologies on the left, have any one of you ever heard of one of these or actually used them? No one, okay. It's exactly what I experienced from when I talked to ML people at HZDR, so I'm not surprised. So maybe it would be interesting to have a deeper look at them. And there are also some associated tools. Many of these are based on the provenance ontology, which has quite a lot of tools available. And actually, this aspect of Jupyter notebooks, for example, and making them more reproducible, especially in the ML domain, could maybe be covered by these ontologies. Okay, so how could HELIPORT help with ML experiments? We could help by describing the experiment within different domains. So I already showed the landing pages and the unique identifiers, which are available, which are the same for all domains. So you could describe your experiment in the ML domain, in the data provenance domain, based on computational workflows and so on. It could also help with data and model provenance throughout the entire project. It could help identify upstream changes, for example, changes in data set labels or new data sets with, which were recorded with different laser parameters, for example. It could help identify downstream changes or benefits rather. For example, if a ML model was used based on this, some laser parameters were tweaked, and better data sets were recorded. This would be an idea. And I already mentioned this for the snake-make workflow example. We could automatically visualize these relationships. And just another add-on we thought about when we looked at some ML papers. There was, for example, you sometimes get these data set and model cards, which describe, for example, provenance of your data. And maybe some aspects of these could be created automatically. Yeah, and with that, I would like to thank you for your attention, and I'm happy to hear your inputs.